Welcome to the School of Life. Life is hard, but you have got to be harder. I'm Mrs. Collins, your life coach. Let's get started with Unit 3, Lesson 7, Rational Functions. All right, so in this unit, we're going to discuss how do we analyze and graph reciprocal functions. Graphing the parent function, we'll start off with y equals 1 over x. Y equals 1 over x. All right, this one looks a little bit different than the ones that we've been looking at, our quadratic, our cubic, our linear functions, our absolute value functions, as well as our square root functions. This one is a little different, so please note those differences, but also there are some similarities. So in this case, we have our general equation will be f of x equals a over x minus h plus k. So that a, that h, and that k, it still is a part of our functions, and they actually still have the exact same purposes. The a stretches it and makes it narrow or wider. The h shifts left or right, and then the k is going to shift up and down. However, with the h and the k, when we're thinking about that left, right, or that up, down shift, we're thinking about something that's called an asymptote. And we're going to talk about what an asymptote actually is very shortly. Okay. So an asymptote is a place on the graph where the domain or range is undefined. We're going to graph it by using a dotted or a dashed line. Every rational function in this unit is going to have two asymptotes. Okay, so when we go back to that, it's where the domain or the range is undefined. Well, let's think of it like this. It's very similar to this. When we have something like 1 divided by an x, whenever we're dividing by a 0, we cannot divide by a 0. And in this case, our answer will be undefined. We can never divide by a 0. So we'll have an undefined answer here. So in any case where we are dividing by a 0 or we're at the bottom, our denominator is a 0, we're going to create this undefined line, which is going to create asymptotes for us. In our work within this lesson, our asymptotes will always be the following. We're going to have one at x equals whatever our h value is, and the other will be at y equals whatever our k value is. These will be our two asymptotes. So in every problem where they ask us for the asymptotes, that's how we'll give it to them. X equals, and then we'll fill in this blank here for our h, and then y equals, we'll fill in the blank for our k. Okay. The very first thing in graphing our parent function for our rational functions is to identify both our h and our k. Our h and our k, so remember that the h is going to be in your denominator down here with your x. The k will be outside. It'll be added or subtracted on. Neither of those are here, so default, as usual, will be 0. So since it's 0, we're going to place 0, 0 in the middle. However, here's what's going to happen. If our x was 0, that means that with our equation, we would have had 1 over 0. We cannot divide by 0. So in this particular case, we don't have an output of 0. Okay, it's undefined, so it's not there. But what we can do is taking 0 being in the middle here, we can go ahead and gather those other values around 0 for our x's. So -1, -2, and going forwards we have 1 and 2. Okay, let's go ahead and do our math. So if we have y equals 1 over x, well in this case we have y equals 1 over, the first value was that -2. So 1 over -2 is the same thing as a -0.5. So this is -0.5. Let's go to the next one. Your equation was y equals 1 over x. So let's plug in our x value, which in this case is a -1. So 1 over -1. And 1 divided by -1 is -1. So output is -1. If we go on to our next one, we have y equals 1 over x. So let's plug in our value. So 1 over, we're plugging in a 1. 1 divided by 1 is 1. So we have an output of 1. And then lastly, we have y equals 1 over x. So that's 1 over. Our last value is our 2. So 1 divided by 2 is 0.5. So here we have a 0.5. All right, so because we have two asymptotes, one will be at x equals, our h value is 0, and our other asymptote will be at y equals our k value, which was 0. So that means that our graph is not going to touch the y equals 0 spot. So we don't have an asymptote there. And it's not going to reach our x equals 0 spot. So we'll have an asymptote here. Okay, so we'll use dashed lines or dotted lines, whichever you prefer to call it. So those will be our asymptotes. All right, from there, as we're graphing our equation, we'll have -2, 0.5, which is about here. You'll have -1, -1, which is, I'm sorry, graph that incorrectly. We will have -2, -0.5, which is about here. And then we'll also have -1, -1, which is here. And what you'll have is a shape that looks like this. Okay, so as we travel, it'll get closer and closer and closer to our x equals 0, whereas on this side, it'll get closer and closer to y equals 0, but it'll never ever touch that 0. On the other side, you'll have a point at 1, 1, and a point at 2, 0.5, and our curve will look something like this. So the main focus within this lesson will be to, 1, identify the transformations in the asymptotes for each of our functions, and then as well as to graph our functions and to write our rational equations. When we're graphing, the biggest thing that I will be concerned with looking at is you are able to identify where your asymptotes are and then graph those asymptotes. So let's look at number 1. We are identifying the transformation and the asymptotes of each of our functions. So remember that at the top, our numerator is our a. Down at the bottom, we'll have our h along with our x. And then we'll have our k at the end. So in this particular case, our a value is 1. So a equals 1. There's no shifts there, no stretches, no shrinks. At the bottom, we'd have our h value down here with our x, but it's not there. So h is defaulted to 0. And then lastly, we have our k, which is equal to 5. Since our k is 5, the only shift that has occurred is we've moved up by 5. Okay, lastly, we're going to identify our asymptotes. So for our asymptotes, remember that that will be x equals our h, and our other one is y equals our k. So as far as the first one, x equals the h value, so x equals 0. And then our other asymptote will be at y equals our k value, which is 5. So these are our two asymptotes. Okay, let's try number 2. Number 2, we have our a value is a 1, so no shifts there. We have that our h value here is, go with the opposite number, a 1. So this means that we have a shift to the right by 1. We have no k at the end, so k was a default of 0. Lastly, we have our asymptotes. So again, that's x equals the h value and y equals the k value. So our x equals our h, which is 1, and our y is equal to our k value, which is 0. These are our asymptotes. Okay, let's try number 3. Number 3, we have an a value of 4. So that means that we have a stretch 4. Okay, note that you have no h, so h equals 0. And our k is also missing, so k is defaulted to 0. So as for our asymptotes, we'll have x equals 0, and we have y equals 0. These are our two asymptotes. Let's try number 4. Number 4, you have an a value of 3. So that means we have a stretch of 3. We have an h of, go with the opposite number, so h equals 4. So that means that we have a shift right of 4. And then we have a k of 6. So this means that we've shifted up by 6. Lastly, those asymptotes. Your x is equal to your h value, which is 4. And your y is equal to your k value, which is 6. So these are our asymptotes. That's where on the graph, if we were graphing those two asymptotes, we'd have dashed lines. All right, so let's try the next one, number 5. We have an a value of 1, so no shifts there. We have an h value of 0 as our default, and we have a k value of -2. So the k value actually gives us a shift, so we're shifting down by 2. All right, and then lastly, picking out our asymptotes, x is equal to the h value, so that's 0, and y equals to our k value, which is -2. These are the asymptotes. Okay, numbers 6, 7, and 8 are you try problems. Go ahead and pause your videos and try each of the problems. All right, so we have our answers for number 6, 7, and 8. For number 6, we have a shift left of 2, and our asymptotes are x equals -2 and y equals 0. For number 7, we have a stretch 3. We are shifting up by 1, and our asymptotes are x equals 0 and y equals 1. For number 8, we have a reflection because of the negative out in front of our fraction. We have a shift right by 3 and a shift up by 2, and our asymptotes are x equals 3 and y equals 2. All right, so next we're going to write rational equations. So we're writing each of the equations given the description. The very first one, we have a translation of y equals 3 over x that has asymptotes at x equals 2 and y equals 5. Well, remember that x equals 2, this would actually be our h value. So our h value in this case is going to be a 2. And then our y equals 5 provides us with our k value. So k is equal to a 5. So if we're plugging those into these two key places for the h and then for the k, then our new equation will be y equals 3. It's still at the top. And then x, so in our general form, it will be x minus our h. So in this case, h or x minus 2. And then plus that k value at the end, so plus our 5. And that's our equation. For number 2, it says write the equation for the translation of y equals a -2 over x that has an asymptote of x equals -1 and y equals -3. So remember that this is our h value, so this is really telling us that h is a -1. And we have our k value Our k value is a negative 3. So plugging those in, we'll have y equals a negative 2, nothing has changed at the top, over x minus was in our formula, and then our h value is a negative 1. And then we have plus our k, so plus a negative 3 as our k value. Let's do some simplifying there. So that minus the negative at the bottom would give us a negative 2 over x plus 1. And then when you're adding this negative, that's the same as just subtracting 3. So this is our equation. Y equals negative 2 over x plus 1 minus 3. All right, number 3, write the equation for the translation of y equals 5 over x that has an asymptote at x equals negative 3 and y equals 4. Remember that this is our h value, so h is a negative 3, and this is our k value, so k is a 4. So we'll have y equals 5 over x. In the original equation, it's minus, and then our h is negative 3, so minus a negative 3. And then we have plus our k, which is 4. Let's simplify the bottom there. So instead of minus a negative 3, it's plus 3. So our final answer will be y equals 5 over x plus 3 plus 4. For the next 3 problems, we're only going to focus on finding the asymptotes by looking at our graphs. So only the asymptotes will we focus on by looking at our graphs. So if we first off look at number 1. Number 1, we have 2 asymptotes, and those 2 asymptotes are, they are these dashed lines that we have here. So this is one of them, and then we have our second one. This is the vertical one. So if we're looking at the first one that I've highlighted, this one is a horizontal line. This horizontal line is going through our y-axis at the point negative 1. So for this line, we'll have y equals negative 1. That's our very first one. And so again, we can easily figure that out because it is a horizontal line. It is going through the y-axis here at the point negative 1, which is here, guys. That's the point negative 1 on the y-axis. So the equation is y equals negative 1. For your second equation, we have our vertical line, and this vertical line is going through the x-axis at the point negative 1 as well. So its equation is x equals negative 1. So basically, for all horizontal lines, your answer will be y equals, and then the number that it's going through on the y-axis. And for your vertical lines, your answer will be x equals, and then the number that it's going through on the x-axis. So writing our final answers here, we have x equals negative 1, and the other was y equals negative 1. All right, let's try number 2. Number 2, we'll look at first our horizontal line. That horizontal line is here. So this one will be y equals, and then it is crossing over the y-axis here at the point 1. So y equals 1 is that first asymptote. And then our second asymptote, we have our vertical line here, and it is going through the x-axis at the point negative 2. So its equation is x equals negative 2. So our 2 answers are x equals negative 2 and y equals 1. All right, then we have number 3, our U-try problem. Let's go ahead and highlight those 2 asymptotes. You have your horizontal one here, and you have your vertical asymptote here. Please go ahead and try the problem. What are your 2 asymptotes? All right, you should find that your 2 answers are y equals negative 3 and x equals negative 3. Those are your 2 asymptotes. So y equals negative 3 is the horizontal one. Notice that your line is going through negative 3 on the on the y-axis, And for your second asymptote, the vertical one, your line is going through -3 on your x-axis. So x equals -3 for the vertical one. All right, for the last part of our notes, we're going to skip over a couple of things. As far as the domain and range, don't worry about that for this set of notes. We are going to identify the asymptotes by looking at our equation. And then what we're going to do is simply graph our asymptotes. The rest of the curves, we're not going to focus too much on for this particular lesson. So we have f of x equals 1 over x plus 5 minus 2. Remember that our general form would be f of x equals a over x minus h, and then plus our k. Okay, also remember that our asymptotes would be x equals the h value and y equals the k value. So let's identify both the h and the k so that we'll know what our asymptotes are. So in our equation, at the bottom of our fraction, 1 over x plus 5, we have that plus 5. Okay, so here we have our h value. But again, remember that the h value is the opposite of what you see, so it's really a -5. And then we have our k value. Our k value is a -2. So when we're thinking about the asymptotes will have that one equation, which is x equals our h value, so x equals -5. And your second one is y equals your k value, so y is equal to -2. Those are our two asymptotes. When we go to graph these, we'll start off with x equals -5. So on the x-axis, let's find -5. It's here. Okay, with it, we're going to draw our vertical line. It's a dashed line, and again, it's vertical. So this would be our first asymptote. And then in looking at our second asymptote, y equals -2, let's go to the y-axis to -2, which is here, and we'll draw our horizontal line. And this is our second asymptote. So the main thing that I'd like for you to worry about for this lesson is where are the asymptotes when asked, or when given a graph. When given an equation, can you identify both the h and the k, your asymptotes as equations, and then can you graph those asymptotes? All right, so let's continue with number 2, remembering that our general form is going to be f of x equals our a over x minus h, and then plus our k. Our asymptotes will be x equals our h value and y equals our k value. So we'll need to come up with our h and our k by looking at our equations. So again, our h would be at the bottom in our denominator down here. Notice that we have no h there, so h is equal to a 0 by default. Okay, also note that I'm going to use a different color so that it matches those other notes over there. Let's use red. H equals 0 by default. And then our k value, there is nothing being added or subtracted, no constants here. So therefore our k value is 0 by default as well. So h is 0 and k is 0. So when we're thinking about our asymptotes, our x equals the h value. Our h value was a 0. And your y equals your k value. Our k value was a 0. So our two asymptotes are x equals 0 and y equals 0. If we go to graph it, graphing the first one, x equals 0. Well, on the x-axis, 0 is located here. So our first asymptote would be our vertical line going through 0. So that's our very first one. For y equals 0, we locate our 0 on the y-axis, which is also here, and it would be our horizontal line through the 0, which is here. So these are our two asymptotes. Just a little zoomed in for you. All right, so let's try number 3. So once again, we're looking for our h and our k. Our h is in our denominator, so we have h equals the opposite of what we see. So the opposite of that negative 1 would be a 1. Our k is here. Our k is a 2. So h is 1 and k is 2. From there, writing our asymptotes, we'll have x equals the h value, so that's 1. And then y equals your k value, which was 2. So those are our two asymptotes. Let's graph them. X equals 1. On the x-axis, we're looking for 1 on the x-axis. 1 on the x-axis is here. So therefore, we will have our vertical line going through 1 on the x-axis. Okay. And then y equals 2. We're looking for 2 on the y-axis. 2 is here. So we'll have a horizontal line going through 2. And we're done with that one. All right, so the last problem is the U-try problem. I would like for you to identify your H and your K and your asymptotes and go ahead and graph those two asymptotes. All right, so your answers. You should have identified H as -1 and K as -3. So your two asymptotes are X equals -1 and Y equals -3. When we go ahead and graph X equals -1, you're again looking for -1 on the x-axis, which is here, and we have a vertical line there. So here is our X equals -1, and Y equals -3 on the y-axis, which is here. You're looking for your -3, which is located here, and we're going to draw a horizontal line through it. And you're done. All right, so when looking at your practice activity for this particular lesson, please ignore, you do not have to fill in the domain and the range for numbers 8 and 9. So you do not have to fill in the domain and range for those two problems. For all other problems, please try them.